All right, so today we're going to be working on identifying key features from a function. So when I look at this graph right here in our first example, I want to try to identify the maxima and the zeros. Now maxima means maximum and minimum. So when we're talking about the local maximum and minimum, because you see how I have those arrows there, that does mean it goes off into infinity, so really that would be the highest point. But if I look just on this graph, the local maximum, the local highest point is right here, right? And that's easy to identify. Like you can look and be like, oh, well, that's the highest point. So we're just going to label that the max. Now how we write that is we write it as a point. So I'm looking at the maximum. That's going to be the point -2, +2. Another way you can write this is just as y equals 2. Because again, looking at that y value, we're not dependent on the x value for maxima, we're dependent on the y value. So that's the maximum. The minimum is the other part of the maxima. The minimum is the lowest point. And if I look at my graph right here, well, it's easy to see that's probably the minimum. It's definitely the lowest point. And so my minimum, same thing, I'm gonna write it as the point. This is the point 0, -2. And again, I can write that because it's in terms of y, as y is equal to -2. It's just telling me my local minimum is located at where y is -2. Got my marker on my shirt. The last thing, and this is a new vocab word, is the zeros. Now zeros are where it crosses the x-axis. So these are x-intercepts. So when I'm looking at identifying my zeros, where does it cross the x-axis? Well, it crosses here, here, and here. Those are at the points -3, 0. It also crosses at -1, 0. And then finally, it crosses at 2, 0. Notice that I didn't include the y-intercept. That's because it doesn't cross the x-axis there. It crosses the y-axis, so it's not a 0. Another way you might see this written as is x equals -3, x equals -1, and x equals 2. And that's because those are the x values for which you have solutions. Okay? So that's going over, again, key features. So identifying the maxima and the zeros. Here we're going to be talking about increasing and decreasing intervals. So increasing and decreasing intervals are easy to identify because you're just looking at the graph, and increasing means where does it go? Up from left to right. So when I look at the graph, well, it looks like it's going up from left to right here, right? That's where the graph is increasing. Now what's tricky about increasing intervals is you don't write them as points, you write them as intervals, which means we're writing them in terms of x. Intervals are always in terms of x, and this is going to come in handy when we're talking about domain later. So it is increasing from what x value to what x value. Well, if I look, it starts increasing at -3, and then it stops increasing at x is equal to 1. So that is my interval. But you remember, we have to put it on brackets or parentheses. So we're going to use brackets when it's closed. Here is a closed circle, so I'm going to put a bracket around the -3. Here is an open circle, and so I'm going to put a parenthesis around the 1 because at x equals 1, again, that's an open circle. So that's increasing. Decreasing is similar, it just goes the opposite way. So when we're talking about decreasing intervals, we're talking about where does it go down from left to right. And so here, it goes down right there, from left to right. So when I'm talking about my decreasing intervals, again, think about the x values. Where does it start decreasing? Well, it starts decreasing at x is equal to 1. And then where does it stop decreasing? It stops decreasing at x is equal to +4. Again, from left to right. So again, we have to keep in mind, am I using brackets or parentheses? 1 has an open circle, so that's a parenthesis. 4 has a closed circle, so that's going to be a bracket. So that's how we identify our increasing and our decreasing intervals. The last thing is taking a concept that you guys got really good at, hopefully last year in integrated 1, but it's the average rate of change. So when we're talking about the average rate of change on an interval, we're talking about what is the average rate of change from the x value -3 to the x value 0. So x is equal to -3 right here. and x is equal to 0 right here. So we're really looking at this interval right here. What is the average rate of change, or what is the slope? Now you know that in order to find the slope or the average rate of change, you need an y values, and right now we only have x values. Lucky for us, this graph is consisted of points, which means I have an x and I have a y. So here, that first point, the x value is -3 given to us by the interval. So it's at -3, and the y value is -1. So that's my x1 and my y1. The second point is 0. So when x is 0 right there, my y value looks like it's about 2. 0, 2. So that's my x2 and my y2. So now it's just a matter of plugging it into this formula, which is again something that you should have been doing since 8th grade. So hopefully really easy for you at this point. The hardest part again is identifying the points, but then once you have the points, it's just plugging them in. So then m is equal to y2, which is 2, minus y1, which is -1, over x2, which is 0, minus x1, which is -3. Remember those double negatives, they become positive. So then I'm going to have 2 plus 1, which is 3, over 0 plus 3, which is also 3. And then 3 divided by 3 is 1. So the average rate of change on the interval from -3 to 0, that's going to be 1. So again, identifying maxima and zeros, which is pretty easy peasy lemon squeezy. And then identifying increasing and decreasing intervals. Increasing, you're looking from left to right, where is it going up? Decreasing, you're looking from left to right, where is it going down? Remember, in terms of x. And the average rate of change, that's just another name for slope, something you're pretty good at. So hopefully that was easy for you. Good job.